Hi there. So, welcome to another episode of the JUXTCast. Today I'm hosting, so I'm Jeremy Taylor. I lead the XTDB project at JUXT. And our guest today is Viktor Leis. So, I first encountered Viktor a few years ago, or at least I counted his name reading various research papers. So, he's quite prolific in the database community. He's probably most famous for the lean store system, which is perhaps an interesting project which we can talk about. But in January, your name came up, Viktor, because a colleague of mine was looking at the CIDR papers, and we noticed a paper that said a critique of modern SQL and a proposal towards a simple and expressive query language. So that prompted us to have a conversation, and here we are a few weeks later, really to explore your thoughts in this area, but also just to get to know you and yeah, put your name in front of our audience. So yeah, you sort of are a big hero for us, and we've read a lot of your work. So it'd be great to hear to share that with our community. So Viktor, I guess to kick us off, would you like to just share a bit about your background, the kind of reasons you got into working on databases and your research interests? That'd be good.
Absolutely great. Thanks, Jeremy. So, yeah. So, let's see. How did I get into databases? So, I'm one of those maybe strange people who always like databases. So, this is not the case for everybody. But I even did kind of my undergraduate grad thesis on databases, and then I worked in industry for a year. Actually, maybe also slightly related to what we will be talking about today. And very unusually, I actually worked in industry uh, programming Common Lisp professionally, writing basically web applications in Common Lisp. And then, I mean, that is now close to 20, no, not quite. Yeah, it's 20 years ago, almost 20 years in the past. And then I worked, then I did my master's degree at TU Munich, doing more databases. And then I did my PhD also at TU Munich. And there mostly it's about high performance database systems. That time primarily database in-memory database systems. Um, and I liked it so much, I decided to stay also on as a postdoc. And we also had the main project that we did during my PhD. Well, it was a big team, but I was part of that. We also had a startup on Hyper, which is the main memory database system that was then acquired by Tableau. And most of my PhD colleagues who also worked on Hyper now still in this Hyper team that's now part of Salesforce via Tableau eventually. And so this is a high performance database. This is my kind of my background, high performance databases. But as I said, I decided to stay in academia because I really like freedom. I really like doing whatever I want to do and change topics also. And so then I was a professor at two other German universities, and now I'm back at TU Munich, still working on databases. So I don't know. That's the story basically.
Well, I can sympathize with some of that. I mean, databases have been my passion for quite a few years now. I don't think I could say I've gotten quite as deep into the stack as you have. Yeah, it's really interesting to hear your background. Thanks. So yeah, I guess this reason that we're having the conversation is around your pet interest. I suppose it is ultimately around sort of languages that are other than SQL in the database world. I wonder if you had any sort of experiences before writing this paper about using other technologies on top of relational systems. Maybe you've used ORMs in the past. Wonder what your thoughts were sort of coming into this writing this
Yeah.
paper.
Yeah, so actually, I mean, as you said, this is indeed not my main research area, and I kind of have so mostly I've been a fan of SQL in the past. So this will has changed, but traditionally I was kind of particularly I like most of the concepts behind SQL, and in the past I for instance used a I mentioned Common Lisp earlier, and at that time we were using, and I think it's still a widely used library called Postmodern in Common Lisp that gives you kind of a more Lispy interface to SQL. It's still basically SQL, but a little bit more orthogonal and with more parentheses. And but in generally, I would say well, I was fine with SQL. And so, as I said, we were really, which is maybe slightly unusual in academia, but I was involved with Hyper, which is the SQL database system, and so um, I also worked. No, that was not my main area, but I also made changes to that part if necessary, adding some new feature. I don't know. Adding, for instance, I implemented window functions at some point, and then of course you kind of had to. But that was mostly on the implementation side. As a user, I have to say, I also use a lot of SQL just as a like basically for data science kind of stuff and analyzing my scientific data, making plots and that kind of thing. I wasn't actually that unhappy until kind of interestingly something like half a year ago. And that was triggered by a keynote at the last SIGMOD, which is a very big database conference. And there was a keynote by Don Chamberlain, who's the co-inventor of SQL. And that was almost like a 50-year kind of a retrospective on SQL and what made it successful and so on. And that somehow got me started to really think deeply about SQL and query languages, and so the one thing that might be interesting and that many people in the database community know, but I think outside is not that widely known, is how SQL actually became so prevalent. Right? So if you read kind of and this is pretty well documented. So the way it happened is basically there was this relational databases at that time, right? We were in the 70s. That was really crazy academic stuff, right? Code wrote this proposal. It was all math, right? And everybody thought maybe it's a good idea, but this will never be practical. So maybe it's a good idea theoretically, but not in practice. And also the query languages looked like math at that time. So people thought nobody will ever use that. And then basically a couple of very young researchers at IBM Research, they made this proposal, SQL, right? And that was just a research paper, and it was not in any product. It was not really at that time not clear that there would ever be a relational product from IBM or anyone, right? So it was pretty researchy. And then the fun thing happened is that Oracle was building a relational database system, and they read this paper and they saw, well, it says IBM. Well, it said maybe IBM Research, but anyway, IBM. And at that time, IBM was super dominant. And so if IBM says this is the language, well, then they implemented that language. So, and then, okay, then Oracle basically came out with the SQL relational database system, and that actually forced IBM or made IBM to also implement and commercialize a relational database system, and also adopt SQL, because that's kind of, so it's kind of this fun interdependence, right? Because if Oracle wouldn't have happened, then IBM probably also wouldn't have brought out SQL. Okay, so that's the story. But if you think about it more kind of cynically, right, this is not a good reason to decide for language design, right? Just the sequence of interdependencies of and basically structural market forces that cause. And since then, basically, we've been stuck with SQL, and so I'm sure we'll get more into that. And from that point on, basically, I started to think about all these issues that SQL has, and then we wrote the paper that you mentioned, right? So, but all of this stuff in my mind is actually pretty fresh, and I basically came to this realization, I guess, later than many other people.
No, it makes sense. Yeah, so I guess my own journey into this was very much interested in knowledge graphs and things with very high cardinality of tables and attributes, where like third normal form modeling would not really be appropriate. So yeah, my own gateway into thinking beyond SQL was that. But yeah, I think for a lot of businesses and people that are just building applications, day-to-day developers, SQL is such a important technology. It's dependable. The engines are very well tested and reasonably efficient. Obviously, I know you have strong thoughts on that, but yeah, there's this idea of the Lindy effect, where the longer something's been around, the longer it will likely to be around. And I guess being 50 years old, SQL is probably going to be around for quite a long while. But I was wondering if you had any thoughts. So there's this idea of like $1 billion mistake. Nulls cost like $1 billion. How much tax do you think SQL actually is on the industry as a whole? Because you've got the database implementers who have to implement it, and then the users have to battle with it.
Yeah, then don't get, well, I think you this is a very interesting take on that, because many people, they say exactly what you say, right? Maybe SQL is not ideal, but it's such a it's a standard and everybody knows it, so it's fine and it's good enough, basically. But I actually think that the damage that you're alluding to is actually ginormous, right? And it's of course indirect, right? It comes basically from the fact that um, SQL is not really a proper standard. So if you, there is of course a standard committee, right, that writes thousands of pages on stuff, right? But this standard is actually extremely bad. It's probably one of the worst standards that there is, and the consequence of that um, is that actually every particular SQL implementation is usually its own dialect, right? And they're not compatible at all. So they are compatible at the level that if you learn the concept of SQL, you can migrate to a different system, but they're not compatible at the level of you can take an application that uses Postgres and just direct it to MySQL and it will work, right? This is not how it works. And so the damage that you're alluding to comes from these silos and lack of competition, right? So people got stuck in with some particular commercial vendor, and it's once you have these huge applications, sprawling business applications on, it's almost impossible to switch, right? And so this is, I think, and so the damage can be ginormous, right? So in my research, I also look a lot at kind of the theoretical efficiency that a particular query can have, or how fast could you execute it on given hardware. And what we see, and this you can actually measure in dollars or euros in the cloud, right? Because you know how expensive different cloud systems are. And what you see that this is mostly for like big analytical queries is that there's often one or two, one is almost always the case, but often two orders of magnitude gap between how fast the systems could be and how fast commercial systems are, or also widely used open source ones. So the gap is ginormous, and I believe indirectly one reason for that is this siloing off and the fact that there's not really not perfect competition. Of course, there's some competition, but it's not enough, right? So once you have some customers, right, you trap them in, and it's hard to get out of that.
Yeah, that makes a lot of sense. Yeah, so anything that can be done to bring about more competition would force engines to compete more effectively on the same sort of workloads. Yeah.
Absolutely,
So
right, and make
so
it also easier to startups and newcomers, right? That's very hard now, and also SQL is just very difficult to implement on the front end. That's also kind of a tax on innovation and competition.
yeah, so our database XTDB, we've just gone through this pain of building a SQL parser and a compiler to do rewrites and all this kind of stuff and compile it down to a logical plan. And it does make you think, wouldn't it be nice to be a little bit closer to the relational algebra?
Yes, yes.
So maybe you could outline then sort of what differences you've proposed in your paper. That's sort of yeah. What are the headline differences between what you're saying and what SQL offers?
Absolutely. I mean, so the one of the starting points that we use in the paper is also we have this data set basically of queries of real world queries basically by students who are taking our introduction to database course and learning SQL, and we have a website where you can easily play around with SQL. And so we have this data sets of more than 100,000 SQL queries from the wild basically, and so if you look at that data set, right, and just run those queries against a database, what you'll see is that 40% of those queries don't work, right? And then you can look at, okay, why don't they work? And what you'll see is that by far the most common error is about 40% of all errors is syntax errors. Right? And this is kind of the starting point also of that paper, looking at SQL syntax, and we have all these examples showing like that it's actually, in particular, if you use kind of nowadays standard and common, but not like standard, not features from the 80s, but features that were added, let's say, in the last 20 years, getting the syntax right for common table expressions and constant table expressions is actually super difficult, right? You have to have the parentheses at exactly the right spot and the commas at exactly the right spot. And if you don't have it at exactly the right spot, then you get syntax error at or near. And it will, if you're lucky, it tell you somewhere the broad area where it's, or sometimes it just says syntax error and doesn't know what the issue is. And so also these error messages are not very helpful, right? So the point is, okay, this syntax is a big issue. And there's also other issues like the way joins are expressed, the way aggregations work, but I would argue that many of them have the same root cause, namely that SQL was actually, when it was designed in the 70s, was much simpler language. So at that time, it still kind of made sense. But then they added more and more stuff to a language that had this fundamental property of looking like English language. Of course, it's not really natural language, which makes it so brittle also, right? And you have all these syntax errors. But adding more and more features, right? Window functions and joins and recursive. Well, joins were always there, but the auto join syntax wasn't there initially. Made the language just super complicated to write, to implement, and so on. So the lesson maybe is that if you're building a language, language will always be extended. You have to build it with extendability in mind. And if you don't do that, then you'll end up in a bad place. So that's one, I think, big part. But you could argue, well, who cares about syntax? It's maybe a little bit annoying. You just try 10 versions until it works, right, when you write the query. But what for me, I really made it even more stark, kind of, that SQL is not the right approach, is if you think about what like your standard SQL query, right, it has these standard clauses: select, from, where, group by, having, order by, right? And when I mean, we're teaching SQL also in university, and so you teach them, well, this is what you just have to remember those clauses and just write them exactly in this order. However, this is not enough, because this is not actually the order that the query actually that you have to understand to know what the query does. So you also have some implicit semantical order, right? So join comes first. So in a way, from clause is first, right? Then there's kind of the where clause, then probably aggregation comes. Then if you have a having clause, you have another kind of where clause, right? And then sort, right? But this is not the order that people write down, right? So you have, but to understand the semantics of a query, you have these two different orders: the syntax order is the semantical order. And you have to memorize both, and you have this mapping in your brain to always go from one to the other, to the other, right? And now the question is, of course, okay, so what's the point of the syntax order if actually the semantical order is there? And the semantical order, of course, is basically relational algebra. And relational algebra is also basically what we have to teach students so that they understand how SQL works. So what's the point of having this other order? And of course, the semantical order that I'm talking about is again a separate order from the order that the query eventually is executed, right? So because the optimizer can reorder things. And so all these points bring you to the question: why don't you directly specify this semantic operator order in a more relational algebra style language? And I mean, many people have proposed that in many different contexts for many different reasons. But for me, I mean, this just makes sense as an educator and just conceptually, right? How we teach SQL. I don't see any reason of going this in direction that SQL takes. And some people claim it's somehow more declarative, but this doesn't make any sense at all to me, right? You have to know relational algebra anyway to just know what the semantics is. And so I think this has been kind of my journey, basically, and that you should directly express uh, the logical operator order. So and this is basically what of course data frame APIs also do, but also what our query language proposal called SaneQL does. So basically, you just specify the order of the operators in the order that kind of makes sense logically, and then you understand what the query does. And then we have a tiny bit of syntactic sugar, which basically allows you, and this is also, we're not the first one to suggest this idea, it's also a very common idea, because with these relational algebras, right, they will be usually heavily nested, right, if you have more complicated queries. And so you want some kind of syntactic sugar so you can have something like a pipe operator, right, like with Unix shells. So because many times you develop queries interactively, so you start with one table and then you join to it another table, and so on. So this is kind of and this is all, like most of what SaneQL is about. It's not super new, right? It's very similar to many data frame APIs.
Thanks. Yeah, and I think last time we spoke, you alluded to mainly sort of thinking about SaneQL as something that would be writable directly by humans. So it's not like S expressions, but in theory it could be programmatically generated as well. Was that a consideration about yeah?
Yeah.
Other...
So Absolutely. I
Correct.
think SQL is so regular, right, that this mapping that you're alluding to, it makes perfect sense, and we haven't done it, right, but there should be, right. So if we were to if we will push SQL further, that's one of the things that we will certainly do, right. So that there's a basic canonical um, programmatic representation or data structure representation that you can send over the wire, that you can also use maybe to implement fancy transformations, more macros, these kind of things. And also, I mean, because it just makes a lot of sense, because in practice, I mean, I don't have any statistics, but I wouldn't be surprised if the vast majority of all queries that eventually end up being executed by database systems are actually not written by humans, but are generated, right? So why do you then go through this kind of weird intermediate format that looks like a natural language, that's hard to generate also, and kind of brittle, and also non-standard, as I mentioned earlier, because, well, it looks like a standard. It's the worst kind of standard because it looks like a standard. It claims to be a standard, but it's actually not a standard. And so you go to this intermediate step programmatically, and then you send it to a database. So I think with this kind of relational algebra style approach, it's also natural to build query builders that just directly build this data structure internally, and then have a standardized format to send it over the wire, rather than concatenating strings, right? What you have to do in SQL, and that of course also brings the risk of SQL injection attacks and all these terrible things, right? So, and that's kind of this wasn't really our starting point, right? But this is also an obvious benefit of this orthogonal approach, right, to query building.
Yep, and the syntax you actually chose, it is, like you say, quite a regular syntax. What was the main language inspiration? Obviously, it's a podcast; people can't see the language. You can easily Google for the Sane QL paper. But yeah, what would you describe as the biggest syntactic inspiration?
Yeah, so my in contrast to my co-author, I mean, he's not a Lisp Thomas Neumann, right? He's not a Lisp person. I'm the weird guy here. But it was designed to look not like Lisp, I mean, but to look just like let's say JavaScript or Java, like just something, because that people are familiar with it, right? It looks kind of non-weird, I think, right? So it looks pretty easy, and just looks like function calls in a script language, right? And so one decision we did, you can argue about that. For instance, this pipe operator that I talk is actually a dot, right? It's not pipe. So because the nice thing about the dot is, of course, if you build this, if you would programmatically build these queries, you can actually, if your programming language supports this kind of operator overloading, you could actually build them, or maybe might not even need operator overloading, but then you could kind of programmatically build these queries, and they would look also the same as the SaneQL language itself. Right? So yeah, basically it was meant to look natural. So you have basically function calls, you have this dot operator, and you have like curly braces for to be able to give you basically a list of expression, list of arguments, that kind of thing. But that's basically it. You don't really need more than that. And that's in a way interesting, right? Because SQL has this incredible amount of pretty baroque syntax, but you really don't need it. And in my opinion, maybe some people will disagree, but I haven't actually had people tell me that's not true. So my claim is that actually the SaneQL is just as readable and than SQL. So it takes 5 minutes basically to learn, and off you go. This is not like SQL. Even for people who who have been writing a lot of SQL, I don't think it's a big, it would be a big change for them.
And am I right in saying that another big distinction is the abstractive power? So SQL, it's notoriously hard to like have reusable expressions and refer to the same thing multiple times, parameterize that sort of thing.
Absolutely, absolutely. So this is also a big emphasis in the paper, and we have a couple of examples. So SQL is as if you take the L seriously, right? Programming language are supposed to be like an abstraction, right? Reuse, right? Don't repeat yourself, right? If you do something, do it once and then you reuse it, right? That makes a lot of sense. Except that in SQL you basically cannot do that. You only have views, right? Or you have common table expressions, which are kind of transient views, and that's all you get. It's like a function call, or it's actually more a procedure call, and you cannot even give it arguments, right? Something like that, right? So you can't even put something in your in your view, basically. Maybe, I mean, with some extension, maybe you can put a constant in there, but it's not like you can implement interesting operators. For example, I mean, there's no way uh, extend the language with operators that look like built-in operators, right? This just doesn't work. And of course, now some people build abstraction themselves by string concatenation, because at some level, right, everything is kind of well, how should you say? I mean, at some point, everything is Turing complete, and you can do everything with everything. But this is not really, right, in practice what you want, right? You want the language itself to be extendable, and so we have these examples in the paper, for instance, that you can in SaneQL, in the language itself, define a new join operator, like a semi join. Right? It might not be the most like efficient way to implement a semi join, and of course, it's a good idea if the database implements it itself anyway. But in principle, you can do it, and then it looks like it's a built-in operator. You can use it for arbitrary input relations with arbitrary attributes with arbitrary types. So I think this is kind of I think something that some other more recent like SQL killers don't have yet, but maybe they will also think in that direction, because the L is actually it is a language. So why don't you give these kind of capabilities?
And so I guess on that theme, I'd be really curious to hear where you sit in the spectrum of wanting to push more compute, more logic into the database. And let's assume SaneQL is like a good route to do that. We're not having
Hmm.
to compile
Yeah,
horrific things down into SQL or put things into WASM or something like that. Like on the spectrum from let's keep doing what we're doing, 3GL languages, sending
yeah.
relational algebra over the wire to a database. Do you think the industry should be thinking more towards let's put as much computation into the database as possible? Mike Stonebreaker just released the DBOS project. They're trying to pick up interest. Put more stuff into the database. Where do you sit on this?
Yeah, that's a very interesting topic you're raising here. So the database people, which I include myself in, of course, always say just push stuff to the database, right? Because we think databases are the most important thing, and this is where things should. And conceptually, there's a lot of truth to that, right? Because many times moving data around is expensive, so you want to push the computation down. Of course, I mean this is not always the case, right? So I don't know if you have heavy kind of deep learning style workloads, right? You don't want to execute them on a CPU in the database, even though actually we had a paper on that as well, that at least for basic linear algebra, if you have a fast in-memory query engine like Hyper, you can actually get pretty remarkably and surprisingly decent results. It's not the case for all database systems, but even that sometimes can make sense, because for instance, if you think not about training huge networks, but let's say inference, right? You already trained your model, and then you want just to, I don't know, classify customer based on some dimensions, right? Maybe whether you give them some kind of promotion or something like that, and you train some machine learning model, and that then predict something, and then you just move the weights of this trained model into the SQL database, and it could be very convenient actually to do the inference and within a SQL query, right? You can do that, and we have a paper on that. So that can kind of make sense. Now, there is also in your question a more, it can be also answered in a more abstract way, or rephrased. Do the abstractions that we currently use in computer systems, right? So the programming language we use, the like operating system interfaces, and also the database interface, currently SQL, are these actually the optimal way to split up systems, right? And I would be very surprised if that's the case. So just my understanding from from the way I see computer science and the industry and research and just the historical development of the field, I think most of these are just historical contingencies and just path dependent. So people did something in the past, and that led to other things as incremental changes, and then over time we are stuck in kind of this world we live in. And I think many of these decisions are actually not optimal at all. And so also this boundary between what the programming a language is, what the database is, I don't think that's actually an ideal boundary. For instance, also just for the reason that usually most applications talk to the database through a network interface, sockets, and that alone often kind of because that has overheads and latencies and so on, is kind of an issue, right? So yeah, this is kind of a very very vague answer maybe, because with abstractions, right, you once you're there and all our thinking is so coupled to, for instance, to these terms: operating system, database system, programming language. We think in these abstraction, in these terms. It's almost hard to see how things could be different, but I think people underestimate how different things could be. And the split between application and database is, in some respects, rough. It is arbitrary and a historical artifact.
And I think for most people listening, you say the word database, they'll just think of Postgres or maybe Oracle. And yeah, obviously Postgres in particular is wildly successful for the amount of capital that's gone into it. Like it's it's never had a huge company backing it for most of its life. It's just a collection of academic researchers and passionate open source developers. But it really is just just happens to be in the state it is in. It's not been pushed in any particular direction in a
Yeah.
long term sense. And maybe to help people understand or visualize how you see Postgres, we're talking about query languages. Obviously, Postgres has its own SQL dialect, but if you could try and decompose how you visualize what Postgres is versus maybe what it could be, or what something that is akin to Postgres in the future could be, like
Mm.
what are the areas that hold something like Postgres back from fulfilling the potential
Yeah.
that everyone wants from it?
Yeah. Yeah. I mean, actually, I'm as a user, I'm a fan of Postgres. It's great in terms of it has great documentation, and it actually, to the extent that it makes sense, it follows the sequence standard very well, which most commercial guys don't. And when it deviates or extends it, it does that in a very very sensible way. And actually, this has led to, and because of this ease of use, good documentation, sensible, as you mentioned earlier, I mean, this has basically almost become a standard now. Everybody copies their semantics, or all the many upcoming systems try that at least. Of course, there will still be incompatibilities and so on, um, but so that's kind of the based on the current abstraction boundaries, because they also follow the standard model SQL behind the socket interface. This is actually, I think, almost from a user point of view, as good as you can get, if you stay in that frame of mind. Now, internally, and the way the system works, turns out to be both for conceptual reasons partially, but also just for implementation reasons. As again, because it's I think it probably was started in the early 80s or something like that. It's just a very very old system that's extremely inefficient. So there's many orders of magnitude that you can be more efficient usually, and there's no single kind of performance bottleneck or anything. It's just that almost everything is over time has accumulated so much kind of overhead, performance overhead, that it's basically not. I don't think it's really possible to save it. I mean, some people start with Postgres and then they over time rewrite everything, but this is basically then you have a totally new system in the end, then, because really it was designed in a totally different world than in terms of hardware than we are today. Right? So I don't know if that answers your question, but that's kind of the broadly my thinking on Postgres. I mean, there's reasons why it got so widely used, and it's better than many other systems in many respects, but not in terms of performance.
Yeah, well, certainly, with your experiences in hyper and lean store, it is orders of magnitude, isn't it?
Yeah, yeah,
In difference.
absolutely, yeah.
Yeah. I guess another angle is yeah, Postgres was yeah, very very successful because it had a very good, like you say, good SQL front end that was stable and people could learn, and it was relatively easy to use. What would you imagine would be the next step for something like Sane QL to be
Mm.
successful in the world? Would it be a Postgres extension? Would that be something you'd like to see?
Yeah, so actually, I was thinking about that. So last week there's a kind of there was a meeting with some other database guys, and at some point I also pitched basically something like my SQL a critique, and also kind of SaneQL, and there was even somebody from the standards committee there, right? So the I think most people know that SQL is bad. Where there's still some disagreement is how problematic that is. So I mean, we had this discussion earlier on kind of the implications of why it's so bad, and I think this is now and this is something I try to push, because I don't think enough people are aware how terrible that is. So I think uh, the first step towards kind of improvement is kind of to realize where you are, and how the current state is. And even that, I think, even if I kind of if this podcast becomes viral, right, and everybody now in the world knows that SQL is a problem, right, it's still unlikely, it's still not enough, right, that suddenly we something like SaneQL, or like a full worked out proposal like SaneQL suddenly from one day to another becomes a new standard, everybody switches it, and everything's compatible, and we're in this utopia, right? So there must be some kind of intermediate step, some kind of path towards there, right? So and I mean, there's a small chance, of course, that a startup comes around and it is so amazing, right? And with this new language, that it will just, because it's so amazing, everybody indirectly also picks up that new language. But I'm not sure that's kind of an unlikely event, and particularly also if it comes from one company, right, then other companies will be hesitant to take it, to adopt it as well. And this is what we're talking about, is kind of a industry-wide and a community-wide adoption effort, right? And it's not a technical issue. It's about how do you coordinate, right? Many different people, many different incentives. But I mean, also at this meeting that I mentioned before, I was discussing it with a friend, and also senior member of the database community, and he mentioned, I mean, there is a small chance, right, that there's probably like a couple of systems, let's say including Postgres, including, let's say, some like upcoming database companies like Snowflake, Databricks, um, and of course some smaller companies and startups. If they would somehow coordinate and say, okay, we built this thing, there's this new standard, it's super open source, right? And but yeah, you need a couple of key open source systems. Postgres is probably the most important one, plus a couple of the big upcoming systems, database systems that still can hope to gain more market share, that gain importance, right? Because for some commercial vendors, right, they totally rely on this login, right? So they will be the last one to adopt this thing, right? So, but there is a sliver of hope, basically, that some of these companies, if somebody would work out this new language, new standard, and also like have very good marketing, and then you just meet the right people. So I don't think it's likely, but that could be a path. Right?
Yeah. So on the so I guess most of the conversation we've been having is around the transactional side of the ecosystem. On the analytical side, I think there is some evidence of this happening. Voltron Data has been a big advocate of the Apache Arrow standard, which promises zero cost memory transfers, almost like RDMA access. So you could integrate various like polyglot technologies using Arrow. And they've also promoted the Flight SQL standard as well, which is like an attempt to have a vastly more efficient, like socket SQL based
Yeah.
experience. And so that's very much on the analytics side. But do you think on the transactional side you've not really seen that sort of level of interest or excitement in something new?
Well, I mean, the transaction side is always more difficult, right? Because this is kind of mission critical operational stuff that people don't want to touch, right? So, and so there, basically, your only hope is kind of new startups adopting this kind of thing. But if we manage to get this thing out in the analytical world, then I think over time it could also be adopted in the more operational world. So I think that would be my but your point is actually a good one also, that there is this this trend of disaggregating database systems, and with open storage format, open query engines, and so on. And so this new language standard could be, it's, in a way, it is almost a prerequisite to bring this entire vision into fruition, right? Because you need kind of interoperability if you want to have a pluggable query engine with the query optimizer. Right now, everything is tightly coupled and have very subtle dependencies. Conceptually, it looks very easy, but in the details are often what can kill you. The specific semantics of the optimizer and the query engine and the storage layer, right? But many of these things would be much clearer if the language itself would have a clear, well-defined semantics, right? So you could argue that exactly there is this window of opportunity right now, because this ecosystem is kind of open source components, disaggregate database engines is kind of happening. And with SQL, things are terrible, right? As I said, the SQL standard is just extremely underspecified. If you have an expression like a divided by 2, you have no idea which data type the result will be. Anything can happen. Every SQL system intentionally deviates from the standard, and also has extensions and so on. So and the semantics is just generally very, very unclear in many places, right? And or intentionally implementation defined. And so if you want, yeah, so I think there is a window, let's say it like that, because SQL is so bad, and there is some momentum right now on this open data engine front.
Yeah, and I guess the counter to that direction is the rise of various cloud databases, cloud vendors, who may have sort of open core engines, but ultimately they're building big database platforms, which is fair enough. But like, do you feel like that is potentially problematic to making progress in this area when most of the investment in the industry is actually sort of building these moats rather than open source?
Yeah, I don't know. I mean, there's also these, and there's also even commercial interest in these data lakes, like Iceberg and Hoodie and so on, and they are kind of directly trying to get rid of this silo world of proprietary data warehouses that lock data in. So I think, of course, I mean, there's different players with different incentives here, right? So it's true that some of them might already be kind of in the mode of these cloud players, already in the mode of trying to lock people in. But I think there's still also many new developments, and yeah, so there is a little bit of hope. I'm not like super optimistic, but I mean, the first step is really just creating awareness, right? And then um, I think also you need a standard, right? It doesn't have to be a formal like ISO standard or anything, but it needs to be something that looks like a standard and has well-defined semantics. Because I think without a standard, because this is what you have right now, there's many people who like, I mean, we contribute to that, right? So by creating a new query language, right? It's easy to come up with a new, well, it's not easy, but it's many people, it's fun to come up with a new query language. And so then you have all these sprawling languages, and I think at this point you want standardize again towards something that's significantly better and has a well-defined semantics, because then the kind of database world would I think be over time would become amazing. And also you can get a lot more innovation there, right? You can negotiate the shift between the application and the database system much more easily. And so all these this high level point that we discussed earlier, now it's just very hard. They have different data types, different semantics, that's even not clear what they are. And so once you have that, the I think the benefits would be, in the long run, would be tremendous, and they are very much underestimated right now.
Yeah, well, certainly there's a dozen probably startups right now trying to use LLMs to write SQL queries, and they're probably feeling this pain. And there's a whole cottage industry which wouldn't need to exist if there was a Sane query language.
Absolutely, but I always say that, even because people, of course, nowadays bring up LLMs, because don't LLMs solve all the downsides of SQL? But of course, even for an LLM, it would be easier to write a sensible Sane language and not SQL, right? So they do the very similar errors actually than humans do, right? They also miss some commas and some parentheses and so on. Yeah.
Yeah, well, they learn from us, right? So that
Yes,
makes sense.
exactly.
And another sort of trend we see discussed a lot, and I guess overlaps with conversations we've had, is this convergence between transactional and analytical systems. And uh, people want to build for a kind of scale now in their transactional systems that implicitly they're going to want to do analytics. And if they're trying to push Postgres to its limits right now, they're going to have to scale up and maybe have some read replicas. But like, how do you feel those trends will change over time? Like in having this conversation in 5-10 years, do you think generally people will just choose to have one system, regardless of the query language? Do you think it's possible?
Yeah. So I mean, you brought up kind of two directions, right? One is scalability, and the other one is kind of what we database people call maybe like the hybrid workloads or HTAP workloads, OLTP and all up in one system. And so conceptually, if you go back to historically, right, this distinction, well, scalability was always a goal in the database systems, right? The extent to which it has been achieved is indeed can be argued about. I don't think we're there yet. The other aspect of like these two directions, right, transaction analytical, or these two like stereotypical workloads. I mean, this has been something that database people at some point invented because they couldn't actually solve the problem properly. Because if you read the original relational papers, they don't talk about such a split. And if you could even argue that this is the beauty of the relational model, that it can do everything. Right? You can have transactions and arbitrary queries, but without upfront kind of deciding on which queries are possible, right? So in a way, if you think about the relational model, what it promises implicitly and explicitly, it's totally against this split. And so, and the reason why the split became kind of a standard thing is because the systems were not good enough, not fast enough. If you put everything together, um, and so people at some point, or many people, not all people, kind of gave up and say, okay, this is just too hard of a problem. Let's split it into two slightly different, slightly simpler problems. um, Now, so I don't expect kind of in the next 1, 2, 3, because this is a very hard problem. People have been working on it for decades, and I personally also worked on that hyper. It was actually designed to be a hybrid systems, and but turns out it's super hard, and it's almost like an order of magnitude harder than solving either of those problems separately. And this is why, for pragmatic reasons, even in research, most people then say, I'm in this box, I'm in this box. But of course, the reality is as you said, I mean, people don't want these separate boxes and moving data around. So I think there is and there's no conceptual reason why that's not possible. It's just hard. And so this is why database research is still as relevant as ever. So I think we should be working on that. And the scalability discussion, right? The other point that you brought up is, I mean, I would split it kind of into two things. So first of all, current systems are right now just very inefficient, right? In terms of, if you look at how fast the hardware is, let's say how many IO operations your SSDs can do, and then you put a Postgres on top, and then you measure how fast you can go, and then you compare those two. The gaps is ginormous, right? So most systems are just not efficient. So there's orders of magnitude just in terms of inefficiencies, and then there's of course research systems. You already mentioned LeanStore. That's our kind of prototype storage engine. Um, it can get much closer to these hardware bounds, right? So this is also a form like, it's not really scalability, it's just exploiting what's there, right? And that alone is kind of, there's huge gaps. And then the next step is, of course, okay, how do you scale this up on ever bigger machines and then eventually scale out, right? And so that's all these points are still, after 40 years and or more of database research, they're still active areas of research, and we're working on it, and many other people are working on it. And so I don't think there's any reason to think there will be. I mean, I think people think interesting things are still happening and will keep happening.
Yeah, certainly it's true. The more I learn about databases, the more I learn there's so so much time and energy is poured into this area, and it's only expanding. The number of papers getting submitted, etc. It is always good to see. And I guess what prompted that last question was, if we do want to see a post SQL world, do we have to solve the transactional side before the analytical side, or if these worlds are converging anyway, do you sort of just move to where the puck is heading?
Yeah, I mean, my hope is actually that mostly the language side and the query processing side, this is to a large extent orthogonal. Yeah, the language side from the query processing side and also from the storage side. So right now it's not like that because the SQL semantics is not really standardized. But once it is standardized, I think you can split up these problems a little bit up. Right? So I don't think it's there's such a conceptual dependency of so the effect of the query language on these kind of low level performance things and whether how you scale and whether you're a hybrid system or a specialized system is indirect, right, through this the fact that the standard is not well defined. But once you had a clean, well defined standard, well defined data types, then it makes kind of brings in innovation, makes building these components makes them easier, right? But conceptually, the people know many database components how they can be developed roughly separately, right? At least usually to 99%. Sometimes you have some kind of weird things, but we of course also try to make our database system internally split them into components that are layered and so on. And so that would be my hope. Yeah.
I think it's something in software engineering is just continually relearning is the importance of having proper, clear separations of concerns, disaggregation where possible.
Absolutely, but of course, the in a way everybody agrees with that. But of course, the difficulty is exactly knowing where these layers are and what the interfaces are. Once you have all the layers and interfaces, the implementation is almost like trivial. But
yeah, well, that's why we're glad people like you are really focusing on these problems. Find out those layers. So I guess we should probably close up. But I wondered if you had any closing thoughts you wanted to share, maybe some advice to engineers who are curious about database technology, like what is a good angle to start learning more about databases.
Yeah. I mean, so I'm a fan of Andy Pavlov's online material. So he publishes all both his research seminar talks on YouTube and also his advanced databases course. And he has usually also very, very well curated list of research papers. So I mean, you can watch his courses or his lectures, but also just read the paper list. So I think they are very, very well selected. So if you're interested into high performance database systems, that's I think a very good starting point. And then I think that's what I would recommend to everyone.
Yeah, I think I'd echo that. The whole CMU setup is pretty awesome. So, all right. Well, thank you, Viktor. It's been a really interesting chat. I hope everyone's enjoyed listening. And yeah, I hope to see you and talk to you again soon.